We will start vector algebra and rectangular coordinates. Vector algebra includes adding and subtraction of two vectors and scalar multiplication. Before starting vector algebra, we need to define scalar and vector. Scalar is quantity whose value is represented by a single number. In other words, scalar has only magnitude, doesn't have direction. The example of scalar is temperature and time, position, and so on. On the other hand, vector has both magnitude and direction. The example of vector is electric field intensity, electric flux density, magnetic field intensity, magnetic flux density, and velocity, and so on. The difference between scalar and vector, there is direction or not. If some quantity has direction and magnitude both, this quantity is a vector. Since in this course we deal with vector quantity, addition and subtraction of two vectors is important. There are two methods to find addition and subtraction of two vectors. The first method is parallelogram law, and second method is triangle law. In parallelogram law, we have two vectors, A vector and B vector. Firstly, we coincide initial point of vector A with initial point of vector B. Then we can create parallelogram. And then diagonal vector of parallelogram is adding up vector A and vector B. Subtraction is similar to addition. A vector minus B vector is A vector plus minus B vector. So we find minus B vector. We have A vector. And minus B vector has opposite direction of B vector and has same magnitude. This is minus B vector. We can create parallelogram with A vector and minus B vector. And then diagonal vector is A vector minus B vector. This method is called parallelogram law. And second method is triangle law. We have A vector and B vector. A vector and B vector. Match endpoint of vector A and vector B initial point vector B. Vector from initial point A and endpoint B. This is adding vector of vector A and B, vector B. Subtraction is similar to addition. We find minus B vector. We have A vector, and minus B vector has opposite direction of B vector and has the same magnitude of B vector, like this. So vector from initial point of A vector and end point of minus B vector is A vector minus B vector. So this method is called triangle law. How about scalar multiplication? Scalar multiplication is scalar multiply vector. This is called scalar multiplication. Scalar multiplication is scaling magnitude of vector. Direction keeps same when scalar A is positive, or opposite direction when scalar A is negative. We have four cases. Case 1 is scalar A is greater than 1. At this case, we have vector A. Direction of A vector is same as A vector. The magnitude of A vector is greater than A vector. We can draw A vector like this. Second case is scalar A is between 0 and 1. We have A vector. A vector has same direction as A vector and magnitude of AA vector is less than A vector. We can draw AA vector like this. Case 2 and case 3 is scalar A is less than -1. We have A vector. The direction of AA vector is opposite direction of A vector, and the magnitude of AA vector is greater than A vector, like this. This is AA vector. Case 4, scalar A is between -1 and 0. We have A vector. The direction of AA vector has opposite direction of A vector. However, the magnitude is less than A vector. Right? This is a scaling function. The scalar multiplication is just a scaling magnitude. The direction depends on the sign of scalar A. The next topic is rectangular coordinate system. In this course, we have 3 coordinate systems: rectangular coordinate system, cylindrical coordinate system, and spherical coordinate system. At this time, we will discuss about rectangular coordinate system. In rectangular coordinate system, the point P is described as XYZ axis. We can draw XYZ axis, Y, X, Z, and point P is x1, y1, z1. One, z1. In the rectangular coordinate, we can create rectangular parallelopipe like this. We can create parallelopipes like this, and we can find point P is intersection of x equals x1 plane, y equals y1 plane, and z equals z1 plane. What is x equals x1 plane? X equals x1 plane is yellow plane. This yellow plane is x equals x1 plane. Y equals y1 plane is green plane. This is the y equals y1 plane. Z equals z1 plane is sky blue color plane. This is the z equals z1 plane. The intersection of these 3 planes is P. In a rectangular coordinate system, we can find P at intersection of these 3 planes. So we use rectangular parallelopipe. We can find point P at intersection of these 3 planes. Rectangular parallelopipe has 6 surfaces and 3 differential areas. The 3 differential area is dx dy, dy dz, dx dz. In case of dx dy, differential area of bottom surface and top surface. The bottom surface area and top surface area is dx dy. This is dy dx dz. In case of dy dz, differential area is front and back plane area. The front plane is this plane. Back plane is this plane. This area front plane and back plane area is dy dt. In case of dx dy, it's right and left plane. This is a green plane, right plane and left plane. This is a right plane, left plane, as a front, back. This plane, the bottom plane. This is the top plane. So we can find differential area in rectangular coordinate system. And differential volume is dx multiplied dy multiplied dz. The differential length of rectangular parallel pipe is square root dx square plus dy square and dz square. So today we will discuss adding and subtraction of two vectors and scalar multiplication and rectangular coordinate system. Thanks for watching this video and see you next lecture. Bye bye.